So did you revise the topic, the previous topics? In the electrophilic substitution reaction is very, very important. Okay, so just remember this, which type of reaction it is, Friedel-Crafts alkylation, acylation. Okay, so these topics are very, very important. Halogenation. Okay, so just keep in mind which reagents we will use and so from which reagent, which is your electrophile. And that electrophile will attack the ortho and para position. Okay, and you know very well the para product is your major product. Okay, and you know all the reasons I already have discussed in the class. Okay, so this is very important. So then let's start the chapter. Okay, so I think we should start the topic. Okay. Okay, so we have discussed the electrophilic substitution reaction. Okay, now the question here is, haloarenes are less reactive towards electrophilic substitution reaction than benzene. Explain. What is the reason? Okay, you have to write down the answer. Okay, sometimes in the exam, the direct question can come like haloarenes are less reactive towards electrophilic substitution than benzene. Explain. Give the reason. Okay, so what is the reason? So see, this is your okay. So this is your haloarene. Okay, when the halogen group is attached to the benzene ring, so this is your haloarene. So due to a strong minus I effect of halogens, so halogens क्या होता है? They just show minus I effect, inductive effect. So if you don't know what is inductive effect, so let me explain it first. So inductive effect is basically a permanent polarization of electron density, right? And there are two types of inductive effect. होता है आपका प्लस आई इफेक्ट, ओके, एंड द प्लस आई मींस पॉजिटिव इंडक्टिव इफेक्ट. Plus I means positive inductive effect, and positive inductive effect is caused by electron donating group. Okay, what happens when some plus I group, the group which shows the plus I effect, just like your alkyl group. Okay, alkyl group क्या होता है? Just like your R group, like your methyl CH3. Okay, and any negatively charged group, so they exhibit this type of effect, plus I effect, positive inductive effect. Okay, so positive inductive effect is due to the electron donating group. If electron donating group, suppose electron donating group just like your CH3, this is a toluene, and this CH3, which is a alkyl group, is attached to the benzene ring. So this is your electron donating group. It gives the electron, ये क्या करेगा? Electron को donate करेगा to the ring, towards the chain. So what plus I effect? So due to this plus I effect, so it's a group. Plus I group means it is caused by the electron donating group, and electron donating group basically it donates the electron. So what happens when a electron donating group is attached to the benzene ring? So what happens? It pushes, right? It basically ये क्या करेगा? Donate करेगा. ये अपना electron क्या करेगा? Donate करेगा ring को. So basically it push the electron density on adjacent atom. It push the electron density towards the chain, तो ये क्या कर रहा है? पुश कर रहा है, because it has electron and the electrons क्या कर रहे हैं? रिंग की तरफ पुश कर रहा है, उसे पुश कर रहा है, right? So what happens due to this plus I effect? What happens? The electron density increased on the adjacent atom, okay. So and basically this plus I effect basically which type of group exhibit plus I effect? So alkyl group and the negatively charged groups. Okay, and this effect plus I effect is can increase the basicity, and it basically stabilize the carbocation. ये क्या करता है? आप stabilize करता है कार्बोकैटायन को, stabilize कार्बोकैटायन and increase the basicity. Basicity increase करता है, basicity increase करता है. Okay, but in this case we have to discuss the minus I effect. Now minus I effect is just opposite of plus I effect. Okay, so if on the benzene ring, if minus I group is basically halogens. Okay, minus I group कौन सा show करता है? Basically minus I effect is exhibits by a group like halogen show करता है, and like your NO2 nitro group. Okay, so this type of group halogens, your electron withdrawing group basically. Minus I effect is shown by electron withdrawing group that withdraw the electron from the ring. Okay, suppose we have a benzene ring, okay, and the chlorine is attached. Basically this is your haloarenes, okay, जिसकी हम बात कर रहे हैं. So haloarenes, when the halogen is attached to the benzene ring, what happens? So a halogen is your electron withdrawing group, right? So basically ये क्या करेगा? Because its की electronegativity is very much high, right? This is electronegative element, so it has a tendency to pull the electron towards its. ये क्या करेगा? जो रिंग से इलेक्ट्रॉन डेंसिटी को खुद की तरफ पुल कर लेगा, right? So this type of group, the electron withdrawing group, pulls the electron density away from the chain, right? Which creates the partial positive charge on this ring, Due to this effect, it increase the acidity and destabilize the carbon. ये क्या करता है? Destabilize कर देता है कार्बोकैटायन. Okay, so this is the difference between inductive effect plus I effect and minus I effect. Just remember, plus I effect is caused by the electron donating group, and you know very well what happens when the electron donating group is attached. So it just try to give the electron, it just donate the electron to the ring. And if it give the electron, donate the electron, so the electron density on the ring, okay, increase, right? Electron density increased on the ring. Okay, And what happens when the electron withdrawing group is attached to the benzene ring? So it just pulls all the electron density away from the chain, which creates a partial positive charge. Okay, जिसकी वजह से यहाँ पे क्या होगा? Partial positive charge. And you know very well, electrophile is again a positive charge. Electrophile is again a positive charge. Electrophile क्या होता है? Electrophile, electron loving, which is electron deficient होता है. That electrophile has a lack of electron. Has a lack of electron. Electron deficient species होते हैं electrophile. That's why they love electron. They want electron. They want more electron. Right? So what happens when the electron withdrawing group is attached? So we know that in haloarenes, we are talking about the haloarenes. Haloarenes means benzene के ऊपर क्या है? Halogen group. And we know that halogen group shows minus I effect. Minus I effect means it just pull all the electron density towards itself, जिसकी वजह से क्या होगा? चेन पे partial positive charge आ जाएगा, right? So here the partial positive charge. So partial positive charge. So when the electrophile comes and try to attack this carbon, so here क्या होगा? यहाँ पे repulsion feel होगा, right? There the repulsion, इनके बीच में this carbon position and the electrophile, इन दोनों के बीच में repulsion create होगा. Due to that, haloarenes are less reactive towards electrophilic substitution reaction than benzene. Clear? Jubita and Muniba, is it clear? Why haloarenes are less reactive towards? Yeah. So just remember, due to the minus I effect, haloarenes show minus I effect. Due to minus I effect, the electron density in the chain, basically in the ring, in the benzene ring, it basically electron density reduces. Okay, there you feel the decrease in the electron density, and due to the decrease in the electron density, it feels partial positive charge. That carbon attains partial positive charge, and due to partial positive charge, when the electrophile come, they try to approach that carbon, so they it feel repulsion. Okay, so वहाँ पे उसे problem होती है, थोड़ा difficulty होती है to attack that position. Okay, but the electrophilic substitution is possible, but for a time लगता, the rate of reaction is less, and the haloarenes are less reactive towards electrophilic substitution than benzene. But in benzene there is no electron donating or electron withdrawing group. So electrophilic substitution reaction is very much easy in benzene than the haloarenes. Okay, now you can write down proper answer. Okay, just you can plus I effect and minus I effect. If you want to write in notes, you can. In your own language, you can write minus I effect is due to the electron withdrawing group. And electron withdrawing group, you can write down the examples like halogen and your nitro group, NO2 group. And plus I effect is caused by electron donating group, just like your alkyl group and any your negatively charged part. Okay, now write down the proper answer. So due to strong minus I effect of halogens, the electron density in benzene ring decreases. And this slows the attack on electrophile. Okay. And if you want to elaborate, you can elaborate in your own words. Okay. So that's the reason why haloarenes are less reactive towards electrophilic substitution than benzene, due to the strong minus I effect of halogens. Okay, next question is halogens are a strong electron withdrawing group, but haloarene gave ortho and para products on electrophilic substitution reaction. Explain why. Explain why. Do you know? Like, what would be the answer? Halogens are a strong electron withdrawing group, right? Due to the minus I effect, right? But haloarenes gave ortho and para products on electrophilic substitution reaction. Why? So see, एक तो इफेक्ट होता है ये माइनस आई इफेक्ट ड्यू टू द हैलोजन. Okay, the strong withdrawing group which is present, which is attached to the benzene ring. But in the benzene ring, you know very well, there is a resonance. वहां पे दूसरा effect भी है, resonating effect, right? And you can say mesomeric effect, plus M effect. Now, what is plus M effect? Do you know? What is plus M effect? Do you know? Tell me. Positive mesomeric effect. No? So the mesomeric effect is also known as resonance effect. And resonance effect, you know very well, it is caused due to the delocalization of pi electrons or the lone pairs in a conjugated system. So benzene हमारा क्या है? This is a conjugated system, right? Single, double bond, then alternate single and double bond. Okay, so we know that benzene, see, suppose this is अगर double bond की बात हो रही है, तो this is your sigma bond. First sigma bond will be formed, and this is your pi bond. Right? So, and we know that pi bond, sigma bond जो होता है वो constant, वो immobile होता है. They can't move. Sigma electrons can't move, but the pi electrons, they are mobile. They can relocate itself. Okay, and they participate in the delocalization and resonance. They just create resonating structure, right? So mesomeric effect or the resonance effect both are same, right? And they involve basically the delocalization of pi electrons. What happens? Pi electrons delocalize. They move in the basically benzene ring, right? And when they, due to the delocalization of the pi electrons, they show the resonance. Okay, they show the resonance. So the electron density basically it increase at ortho and para position. Right? I think we have discussed this. ये हमने discuss किया था basically. Just a second. Let me check. Yeah, see here. Say this. So when we were discussing the electrophilic substitution reaction, so we have discussed that. Okay, so halogen also shows plus M effect. So the electron density is higher at ortho and para position. So when you draw the resonating structure, see, so this will give the electron, right? And यहाँ पे क्या होगा? It will, you can see the electron density कहाँ पे increase हो रही है? This is the ortho position and this is your para position. Okay, again the ortho position. So electron density, due to the resonance, the electron density increases at ortho and para position. That's why in electrophilic substitution you get the ortho and para product. Okay, so that's the reason you get the ortho and para product. Clear? Okay, so Anisa has also joined the class. Okay, so see. Okay, you can write down now. Write down. So we know that are halogens are strong, strong electron withdrawing group. Why? Due to minus I effect. Minus I effect. But, but, you can write, but since they show means halogen also show resonance और benzene ring की बात हो रही है. Benzene ring also show the resonance. Resonating, resonance, you can say, or plus M effect, plus R effect, mesomeric effect, and plus resonance effect, both are same, right? So plus M effect, so the electron density increases at ortho and para position. Ortho and para position. Okay. So therefore, ortho and para products are formed on electrophilic substitution. Okay, when you do the electrophilic substitution, you will get the ortho and para position, para product. Why? Due to the plus M effect. Okay, so due to the plus M effect, the electron density increases at ortho and para position, and that's why, because we know very well, electrophile is electron deficient. वो कहाँ पे अटैक करेगा? Where the electron density is more, right? So that's why at ortho and para position, when you draw the resonating structure, you will get to know that ortho and para position has more electron density. Okay, so there the electron density is more, so negative charge is more. So due to the electrophile is electron deficient, so वो कहाँ पे अटैक करेगा? Where the electrons are more, right? So that's why the electrophile come and attack the ortho and para position, and you will get the ortho and para product. And the para product is the major product. Okay, always remember the para product is the major product and the ortho one is your minor product. One more thing, see the reactivity, because we have, see, the first question, as we have discussed, the haloarenes are less reactive towards electrophilic substitution, right? And in this, we have written the reason that is due to the minus I effect. So the reactivity is decided by your minus I effect, but the orientation where the electrophile will attack is decided by the mesomeric effect or resonating effect. Okay, so this is very important. You can write the note. Important. Okay, so the reactivity is controlled by minus I effect, minus I, but the orientation is controlled by resonance, is controlled by resonance. Okay, is it clear? Now you can write down. Okay, write down the proper answer. Written? Okay, so the next topic is nucleophilic substitution of haloarenes. Okay, so first tell me, is it possible the nucleophilic substitution reaction is possible in haloarenes? Yes or no? Yes, Munima, tell me, is nucleophilic substitution reaction is of alkene is possible? Yes or no?
Ma'am, can you repeat the question?
Is nucleophilic substitution reaction in haloarene possible or not?
No.
Why? Why it is not possible? See, this is your haloarenes halogen group, right? Now what happens? This halogen group, we know very well, this has electrons, right? So what happened between this is your carbon and this is your X bond, right? So between the carbon and X bond, due to the resonance, there is a partial double bond character. It will give this its electron. It will donate its electron to this, right? And this bond basically you will show. Yeah, and this will shift over here. So due to the resonance, What happened? What happened? Negative charge, and here the partial double bond creates between the carbon and X, right? Between the carbon and halogen, the partial double bond character. So due to the partial double bond character at CX, due to the resonance, it is very difficult to break this bond. It will, it is very difficult to break this bond. And also we know that benzene ring is benzene ring is more negative, right? Due to the sp2 hybridization, it is more electronegative, right? Because on benzene ring the electron density is more, okay, is more. And so when the electron density is more, and you know very well, when the nucleophile again is electron rich, right? So when it come and try to approach this carbon, what happens? It feels repulsion. यहाँ पे repulsion feel होगा. So at a normal condition, at a normal room temperature, it is not possible for a haloarene to undergo nucleophilic substitution reaction. Yeah. So just remember, nucleophilic substitution reaction of haloarene is not possible at room temperature. Okay. But it is only possible at certain under drastic conditions. Only under drastic condition it is possible. Like when you give more temperature. Okay, बहुत ज़्यादा आप अगर temperature देते हो, like high temperature and high pressure पे, it is possible. Nucleophilic substitution reaction of haloarenes are possible at high temperature and high pressure, means at drastic conditions. And second condition is when you attach some electron withdrawing group at ortho or para position. So in these two conditions, haloarenes की electronucleophilic substitution reaction is possible. Okay, I think we have discussed this in the we have discussed the dose process. Dose process हमने discuss किया था. No, we have not discussed this. Okay, so basically in the chemical, yeah, I think we have discussed this in the chemical reaction of haloarenes. Okay, in the chemical reaction of haloarenes, we have discussed those process. Okay, you will see in the notes. Check your notes after the class, and you will get to know. We have discussed that under certain conditions, that is nucleophilic substitution reaction of haloarenes are possible, right? And that is known as dose process. To see what is dose process, first write down. Some points that haloarenes don't show nucleophilic substitution reaction at room temperature. At room temperature. Okay, due to the following reasons. Due to the following reasons. First reason, due to the partial double bond at CX. Okay, carbon of the benzene ring and the halogen. In दोनों के बीच में there will be a partial double bond. Why? Due to the resonance. So the partial double bond at CX due to the resonance is difficult to break. It is difficult to break. Second, the phenyl carbocation is very unstable. Carbocation is very unstable. Okay, when the chlorine is removed from the benzene ring, so obviously this will create a carbocation, and that carbocation is known as phenyl carbocation, and phenyl carbocation is very unstable. Okay, so due to this instability, there is not possible for the nucleophilic substitution reaction. Yeah, again, as I told you, the repulsion between the electron-rich nucleophile and benzene, because benzene is again a electron rich, right? Electron density is high on the benzene ring, and when the electron rich nucleophile comes and wants to approach the benzene ring, so it will feel the repulsion. Okay. Fourth point, the sp2 carbon of CX bond doesn't have enough partial positive charge to attack nucleophile, to attract nucleophile. To attract that coming nucleophile. So these are some reasons that why haloarenes don't show nucleophilic substitution reaction at room temperature. Okay, don't forget this room temperature. Now, at what conditions the nucleophilic substitution reaction of haloarenes are possible? Okay, so write down. First, haloarenes show nucleophilic substitution on two conditions. In two conditions. First condition, which is very, very important. Okay, just remember these conditions. First condition at high temperature and high pressure. High pressure. Okay, means at drastic condition. At drastic conditions only, the nucleophilic substitution reaction of haloarene is possible. Second condition, if you place electron withdrawing group at ortho and para position. Yeah, that is very interesting. Now what happens? See, the presence of electron withdrawing group at ortho and para position will increase the reactivity. Now, how it increase the reactivity? So see, if you take, for example, when I take this, okay, halo, chlorobenzene, right? And in the drastic condition, like in the presence of sodium hydroxide, and at 623 Kelvin, high temperature and high pressure. Can you please tell me which this reaction name? What is the name of this reaction? I think we have done this in the previous class when we were discussing the chemical reaction of haloarenes. So actually we have done this. Yeah, tell me. आप लोग रिवीजन नहीं कर रहे हो? Anyone? Chlorobenzene in the presence of aqueous sodium hydroxide and high temperature and pressure. What will be the product? Yeah, so this is, tell me, see, this is your dose process. This is your dose process. Yeah, so this process is known as dose process. When the chlorobenzene in the presence of sodium aqueous sodium hydroxide at 623 Kelvin temperature and 300 atmospheric pressure. So what happens? First, it forms some intermediate. It forms some intermediate molecule. Basically, it forms sodium phenoxide. Sodium phenoxide. O has negative charge and this has plus charge. This is the sodium phenoxide. First, it forms the sodium phenoxide, and when you put, and in acidic condition, okay, when you give the dilute HCl, suppose you give the dilute HCl. So what will happen? It will give H plus ion, right? It will give H plus ion, and this is your Cl minus. So this H plus ion, it will attach to this O minus. So it will give you phenol. ये क्या देगा आपको? The product will be phenol plus from here the sodium and from here the chlorine, they bond with each other and they will give you sodium chloride. Right, so sodium chloride will be removed from here and you will get phenol. This process is known as phenol. Process is known as dose process. Okay, so it's very important, just remember that. Okay, now see, if you, so this is the basically what is this? So this is your nucleophilic substitution reaction, right? You can see this conditions kya hai? At high temperature and high pressure. First condition, right? At high temperature and high pressure, it is possible for an haloalkene to undergo a nucleophilic substitution reaction. So what happens over here? This, what is nucleophile over here? So OH minus is your nucleophile, right? OH minus is your nucleophile. So first, direct यहाँ पे नहीं होता. First क्या होता है? It just forms the sodium peroxide ion. After that, it when you put the acid in it, when you add acid to that, so you will get phenol and sodium chloride will be produced as a byproduct. Okay, so that's the first condition. Now, second condition, second condition. So see some examples. Suppose we have again the haloarenes. Now, what happens when you attach the nitro group on para position? Okay, what is the position? So this is your para position. Okay, corresponding to this. So para position पे आपने nitro group add कर दिया, and you know very well nitro group NO2 is your electron withdrawing group. NO2 is electron withdrawing group, which shows minus I effect. Right? So what happens over here? So basically, what are the conditions over here? So aqueous NOH, aqueous sodium hydroxide, and the temperature यहाँ पे होता है 443 Kelvin. And the second step में you will give the acid, acidic conditions. Okay, you can take HCl, dilute HCl, anything. So dilute HCl, so H plus, it will give H plus ion. Okay, so what? So it is very simple now. See what happened. So this NO2, when the presence, when the electron, just remember this, this is very important point. When the electron withdrawing group is present at ortho and para position, so it will increase the reactivity. It will increase the reactivity means reaction को क्या करता है, fast कर देता है. It will increase the rate of reaction, right? So it will increase the reaction rate. So what happens? It has a tendency to withdraw electrons. तो ये क्या करता है, electron density को अपनी तरफ pull कर लेता है, right? What happens? This electron, this NO2 is a electron withdrawing group. So it electron को क्या कर रहा है, withdraw कर रहा है. तो basically it just withdraw electron. It just pull all the electron towards itself. So the electron density shift towards NO2, right? Towards NO2 means पूरे ring की electron density it decreases. The electron density here, see this to this carbon, at this carbon decreases. Why? Because this nitrogen NO2, nitro group is the electron withdrawing group, right? So nitro group will pull the electron density towards itself. Due to that, the chlorine will be removed easily. ओके यहाँ पे क्या होगा, ड्यू टू दैट क्लोरीन, यहाँ पे इलेक्ट्रॉन डेंसिटी विल बी रिड्यूस्ड एंड ड्यू टू दैट द क्लोरीन विल रिमूव इजीली एंड दिस न्यूक्लियोफाइल व्हिच इज OH माइनस इट अटैक ऑन दिस ring, right? Because electron density यहाँ पे reduce हो गया, कम हो गया, due to that यहाँ पे partial positive charge आ गया, right? So due to the partial positive charge, the nucleophile will attack to that carbon and it will give you the product. It will give you the product, and here OH will be attached and NO. So that's why I just told you second condition was when you place the electron withdrawing group at ortho or para position, so it will increase the reactivity. So at that conditions, the nucleophilic substitution reaction of haloarene is possible. Is possible. Is it clear, everyone? Yes,
Yes,
clear or
ma'am.
not? Anisa, Jubita, clear? Bachcho? Any
Yes,
doubt
ma'am.
in this?
Yes, ma'am. No, ma'am.
Okay. So just remember these conditions. In these two conditions, the haloarenes undergo nucleophilic substitution reaction. Right? Suppose what happened? Okay, when I just attached one electron withdrawing group at the para position. Now, if suppose more the electron withdrawing group attached to the ortho and para position, there will be more reactivity. Okay, means it will increase the reactivity. So suppose in this question, मैं यहाँ पे भी at ortho position as well as on para position, I attach the nitro group. And the condition is same in the presence of aqueous sodium hydroxide, because sodium hydroxide will give you which nucleophile, OH minus. Okay, and the temperature, suppose temperature भी हमने कम कर दिया, no need to use that temperature, very high temperature, right? Because we are using two electron withdrawing group. So, and the second condition is acidic condition. Now, so again, what will happen? Again, this nitro group, it will pull all the electron towards itself. Electron density pull कर लेगा. Similarly, this nitro group, electron withdrawing group, right? So basically, there are two electron withdrawing group. So they just pull all the electron density towards itself. Due to that, this carbon has partial negative positive charge. Right? यहाँ पे क्या होगा? Partial positive charge means the electron density is reduced. Okay, so the electron density decreases at this position. Okay, due to that, this chlorine can easily leave the ring, benzene ring, and the OH minus, which is a nucleophile can attack that carbon easily. Okay, so more the number of electron withdrawing group at ortho and para position, so more will be the reactivity and easy will be the uh, electrons removal. Or sorry, chlorine halogen groups removal. So OH over here, nitro group as it is, nitro group as it is. Yeah. So nitro group का क्या function है यहाँ पे? They just pull all the electron. It decrease the electron density of the benzene ring. Okay, so that's the function of the electron withdrawing. Similarly, if I attach three nitro group, suppose this is a chlorine, ortho position, para position, and again ortho position. Okay, NO2. Similar condition. Okay, aqueous NaOH in the presence of, and yeah, what you are supposed to do, यहाँ पे देखो मैं temperature decrease करती जा रही हूँ. When I just add more and more electron withdrawing group, I just reduce the temperature because उतनी need ही नहीं है ज़्यादा temperature की, right? So only you can, in this condition, when you attach three electron withdrawing group, so in that condition, just warm. Only आपको warm करना है, ज़्यादा temperature नहीं देना है, right? Only just warm the solution. Okay, and second step, acidic condition. Similarly, again, there are three electron withdrawing groups, so they will just pull all the electron density towards itself and easily this chlorine will be removed and nucleophile, which is OH minus, will attack. Okay, and you will get and this molecule is known as picric acid. What is the name of this molecule? Picric acid. Okay, so what is this? This is 1, 2, 3, 4, 5. 1, 3, 5 trinitrophenol. 1, 3, 5 trinitrophenol है ये. And 1, 3, 5 trinitrophenol is also known as picric acid. This is your picric acid. Got it?
Yes.
Okay. Okay, let's do some questions now. Okay, first question. Identify A, B, C, D, E, R, and R dash in the following. In the following. Okay. In this question, we have to identify these. Okay. Plus Mg in the presence of dry ether. This is dry ether. You will get A. Okay, you have to identify A. Then, when you do hydrolysis, when you add water in this compound, so you will get B. Okay, first equation. Now, second, when Br, it reacts with magnesium metal in the presence of dry ether, you will get C. And in the presence of D2O. Okay, so see, D2O is just like a water. Okay, H2O क्या होता है? Water, hydrogen, dihydrogen oxide. So this is your deuterium oxide. Hydrogen की तरह just a isotope. Deuterium. This is your deuterium. Deuterium is the isotope of the hydrogen, right? So it is just similar to that of hydrogen. Okay, so we just use D2O instead of water. Okay, D2O instead of water. So again, just like a water, when water dissociates, so it will give you H plus ion and OH minus ion. So this D2O, when it dissociates, so it will give you D plus and OD minus. Okay, so just remember that. Okay, so C, when you do hydrolysis, you will get CH3, CH, and CH3, and here D is attached. Okay. The next is CH3. Okay, write down the question and try to solve it. I will ask you. In the presence of sodium and ether, and this is R dash X. Okay, just quickly solve this question. You have to identify A, B, C, D, E, R, and R dash. Done?
Yes.
Okay, Jubita, tell me the first A. What is A over here?
Ma'am, I just wrote the question. I didn't write the answer.
Okay, try to solve the answer. When when you treat this molecule to magnesium metal in the presence of dry ether, so what will happen? You will get the Grignard reagent, RMgX, right? Rx, this is what? ये क्या है आपका? Rx. Rx, this is your bromine, is your halogen, and this is your R. R group is your cyclohexene, right? And when Rx, alkyl halide, when you treat it with magnesium metal in the presence of dry ether, what will happen? You will get RMgX. RMgX, Grignard reagent, right? So that's very easy. आपको R की जगह पे क्या लिख रहा है? The cyclic structure, and you just have to add MgBr. That's the A. That's the A. It's very easy. We have discussed it. Now, when you treat it with water, when you add water to the Grignard reagent, what will happen? This water will give H plus and OH minus ion, right? So H plus will attach to this side, right? This and this Mg के साथ क्या निकल जाएगा आपका? You will get, so basically you will get this plus, what is the byproduct? Your byproduct will be MgOHBr. Okay, so byproduct is not your B, this is your B, this is your B. Clear, everyone?
Yes, ma'am.
That's a previous, yeah, so this type of question can come in your exam. So do the second step, second reaction, this one. Just like the first one. It is just like a first one. Grignard reagent you have to prepare. Yes, Muniba. What is C?
CH3, CH, CH3 with MGBR.
CH3, CH2, CH3. See, इसमें क्या है? We have RBR. We have to check what is R. What is R? Suppose this RBR plus this Mg, when you treat it in the presence of dry ether, so you will get RMgBr. You will get RMgBr, but you don't know what is R over here. Okay, you only know this product. Okay, so you can compare this product by your R. अब R से इसे compare कर सकते हैं. Now see, after, suppose this is your C product, and when you give D2O, deuterium oxide. So what will happen? This deuterium oxide will give D plus and OD minus. Okay, OD minus. So D plus, it goes to alkyl group, and OD minus, it goes to the MgOH ODBr. So basically you will get RH. Okay, you will get RD basically, not RH over here, plus MgODBr. Now compare this product. So you will get RD. So what is R? D is attached over here. So this is your R group. This is your alkyl group, right? So alkyl group is this. So you have to start with this alkyl group. Now you will start with this alkyl group and you will get the product. See, मैं यहाँ पे लिख रही हूँ. Here. So this is your alkyl group. So just see. So, and the D is attached to this. So you will write this bromine. Okay, so this is your alkyl group CH3, CH2, CH3. CH3, sorry, CH3, CH, CH3. Right? So this is your CH3, CH and CH3. This is your alkyl group, and alkyl group से ये क्या attached है? Bromine. Plus when you give Mg in the presence of dry ether, so you will get C. What is C over here? So again, the bromine is replaced basically Mg से आप treat करें, so you will get RMgBr. RMgBr is your Grignard reagent. So R is your this CH3, CH and CH3, and here you will attach MgBr. Got it?
Yeah.
Next step, deuterium oxide. Okay, so what will happen? You will get RD. Okay, R क्या है आपका? R is your alkyl. This CH3, CH2 and CH3, and D is attached here. D is attached here. So this is your known. Basically, we have to find the C. What is C over here? So C is this. This is your C. Clear? Any doubt?
No.
Okay, just write it down. I'm going to rub it. Okay, then we will discuss this one. Can you rub the last one?
Done, ma'am.
Okay, so you try to do this question. So you have to start from this r dash x. Okay, so suppose this is your r dash x. आपको यही find करना r dash x. What is alkyl group over here? Okay, so by which alkyl group is treated with in the presence of sodium and ether to give you alkene. The product is alkene, right? And first tell me this reaction. What is the name of this reaction? Who will tell me? What is the name of this reaction? When alkyl halide in the presence of sodium metal and ether, when you treat this, so you will get alkane, and alkane is double. The number of carbon will be double. जो आपने लिया था कार्बन स्टार्टिंग मटेरियल, so you will get the double the number of carbon.
Ma'am, Wood's reaction.
Yeah, very good. It's Wood's reaction. Okay, so Wood's reaction. Okay, so now it's very simple. See what happened. Basically, क्या होता है Wood's reaction में when alkyl halide, when you treat it with sodium metal and ether, so the number of carbon you will get the alkane, saturated hydrocarbon, but you will get the number of carbon get doubled. Okay, so basically this you can see it is a symmetrical type of a structure. So you can see this is similar to this. Okay, so ये similar है. So you can यहाँ पे क्या you can observe it, and by observing this product you can see that this is your alkyl group. This is your R dash. This is the starting material. Okay, so what is R dash X? So R dash X is CH3, CH, and this is your CH3 and CH3 and X, right? You can write down, अगर आपको confusion है, so you can write down when you treat it with sodium and ether. So what will happen? You will get the product. What is Wood's reaction? Basically, this sodium, it will be removed. Sorry, X halogen group, it is removed, NaX as NaX, and the number of carbon get doubled. Okay, basically, आप यहाँ पे क्या लेते हो? 2 moles of this, 2 moles of the reactant. So 1 mole, when it reacts with this mole, so you will get the number of carbon will get doubled, and you will get this product CH3CH and CH3 over here, and this CH3, 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 and here CH3. This product. Yeah, so that's the Wood's reaction. But we will proceed. Basically, we know the reactant. We know the reactant now. So now you have to identify this D. Okay, now we know what is R dash. So R dash is this CH3, CH, and CH3, CH3. This is your R dash. Okay. Now, when you treat it with magnesium metal, okay, when you treat this reactant with magnesium metal, what will happen? Again, you will get the Grignard reagent. What is this? This is your alkyl group, right? Suppose this is your R dash, alkyl group, and this is your X. Okay, so again, this is your alkyl halide. When alkyl halide, when you treat it with magnesium metal, you will get the Grignard reagent. It's very simple. क्या करना है आपने? You have to add this magnesium here. Okay, so what will be the product? So basically, I'm just writing this is CH, this is CH3, CH3, here CH3, and this is your MgX. Okay, so yeah, you can write like this. Okay, now this is your D. Okay, this is your D molecule. Now, next step, when you treat it with water, again the same step. This water will give you H plus and OH minus ion. And you know very well Mg, it will give you MgOHX, and the hydrogen will attach there. Okay, hydrogen will attach there, and you will get, basically this is your CH3, so you will get this molecule. You will get this molecule. This is your E, plus the byproduct, you will get MgOH OHX, MgOHX. Okay, not necessary to write on the byproduct. You have to only identify the A, B, C, D, E, right? Okay, so that's how we just identify all the unknown molecule in the question. Okay, so basically this is very important question. इस type के questions you can see in your exam. Okay, so only just remember the concept and just revise thoroughly all the concepts. Then only you can do the question. Okay, because you can see over here only two reactions की यहाँ पे बात हुई थी. First reaction is Grignard reagent. Okay, the reaction when the alkyl halide, when it reacts with the magnesium in the presence of dry ether, so it will give you Grignard reagent. After जब आप Grignard reagent का hydration कराते हो, means yeah, in the presence of water, so you will get something different. Now similarly, and Wood's reaction के बाद, there are two types of reaction in this, right? So A is this molecule, B is this molecule, C is this. Okay, now D molecule, D is this, okay, E is this, and your R dash. R dash ये है आपका, and what is R? Is R, okay, so I just erased it. So R is basically, this is your alkyl group. CH3, CH2. Okay, so basically what is R? So R is your CH3, CH, CH. Okay, so we just identify all the unknown molecule. Is it clear? Any doubt in any step? So you can ask बच्चों. Anyone? Any doubt? Anisa, Jubita, Niba? Hello? Any doubt?
No, ma'am.
Okay. Okay, next, write on the next topic, chirality. Okay, what is chiral molecule, chiral carbon, and what is chirality? Okay, so we will discuss that. So, what is chirality? Chirality क्या होता है, and what is chiral molecule or chiral carbon? So, see, in chemistry, chirality basically refers to the property of a molecule that is non-superimposable on its mirror image. Okay, non-super. If a molecule is the basically chirality, it's a property, the property of a molecule in which a molecule is non-superimposable on its own mirror image. Okay, it means that a chiral molecule and its mirror image, and उसके mirror image को हम क्या कहते हैं? Enantiomers. Okay, basically the chiral molecule and its mirror image, they are known as enantiomers, and they cannot be placed on top of each other, and they can't perfectly match no matter how they are rotated. जितना भी आप rotate कर लो, they will not superimpose with each other. Okay, so that's the chiral molecule, and that property is known as chirality. Clear? See, chiral molecule क्या होता है? Basically, just like a common example, just take common example is your hand. Okay, so your left hand and your right hand, basically they are suppose they are a mirror image of each other. Okay, so when you put your left hand on your right hand, so what you feel, they are not superimposable with each other. Okay, so they are not superimposable with each other, so we call it as they are chiral, and this property is known as chirality. Now is it clear what is chirality and what is chiral molecule?
Yes, ma'am.
Okay. Okay, so write down what is chirality, property of a molecule that is non-superimposable on its mirror image. And write down what is chiral molecule or chiral carbon. Basically, we will talk about the chiral carbon. Okay, chiral carbon. What is chiral carbon? So carbon attached to carbon, which is attached to four different groups. Four different groups. Different atoms or groups you can write. So that type of carbon is known as chiral carbon. Okay. Example, if I say like CH4, CH4. So what is the CH4? CH4 is just like this. So tell me, is it chiral or not? Is it chiral or achiral? Achiral means which the carbon is not attached to four different type of atom or groups. So this CH4 methane molecule is chiral or achiral? Yes, Jupiter, tell me
Chiral.
how it is chiral. What is the definition of chiral carbon or chiral molecule? The carbon, see, you have to check. This is your carbon, right? So this carbon is attached to four different atoms or groups. But in this, carbon is attached to this hydrogen, hydrogen, again hydrogen, hydrogen. All atoms are same. So this is not a chiral carbon, right? So this is not a chiral carbon. This is achiral. This is achiral. Is it clear?
Yes, ma'am.
Okay, so you have to check that carbon is attached to four different groups or atoms or not. Suppose if I give you this carbon, hydrogen, bromine, or bromine, and this chlorine. Now, Anisa, tell me, is this carbon, a chiral or not?
It's chiral because it's like four different atoms or groups.
Are you sure? Muniba, tell me, is she correct?
No,
Is
ma'am. There are
this
two
carbon?
same.
Yeah, you can see. बच्चों आंख बंद करके आप देख रहे हो. See, this is bromine group, and again this is a bromine group. Two bromine groups are attached to this carbon. So this is not a chiral. This is not a chiral carbon. All four groups should be different. All four groups should be different. Then only this carbon is known as chiral carbon, right? So again, this is not a chiral carbon. If I attach, suppose carbon, here hydrogen, bromine, here chlorine, and here another CH, right? Now tell me, is it chiral? Yes, it is chiral. You can see this carbon is attached to this bromine, this hydrogen, this chlorine, and again this methyl. So this carbon is chiral. But this carbon, when I talk about this carbon, so this carbon is not chiral. Why? Because it is attached to three hydrogen and this one carbon. Okay, so three hydrogens are same, so it is not a chiral carbon. Okay, so in a molecule, it is not always compulsory that only one chiral carbon will be there, right? More than one chiral carbon भी होते हैं. Okay, so just remember you have to check each and every carbon whether it is attached to four different atoms or groups or not. If that carbon is attached to different four groups, okay, four groups, carbon when attached to the four different atoms or groups, then it is known as chiral carbon. Okay, so just remember this. Okay, let's do some questions. Suppose like this is your molecule. Okay. Now see, this is a molecule. Okay, you have to check which carbon is chiral. Because in this molecule, you can see you have 1 carbon, 2 carbon, 3 carbon, and 4 carbon. 4 carbons are there, right? 4 carbons are there, and you have to check which carbon is chiral. Okay, so we will start when you give the number 1, 2, 3, and 4, right? So if you see over here, so this carbon has 3 hydrogen, right? यहाँ पे क्या है? 3 hydrogens है इसके पास. This is methyl CH3. Okay, so this is not a chiral carbon. Now see second carbon. So second carbon has 1 bromine group, 1 methyl group, right? This is your CH3. This is your methyl group, 1 hydrogen group, and what is this? This is your CH2 group. Okay, when you draw the open structure, so open structure is the CH3, right? This is your C. This is your bromine. Yeah, this is your hydrogen. This is your CH2 and this is your CH3. Okay, that's the structure. Similar structure. So when you give 1, 2, 3, 4, the number to this carbon. Okay, now check the second carbon. See the second carbon. Second carbon has 1 bromine group, 1 CH3 methyl group, 1 hydrogen group, and 1 CH2. All groups are different, right? So this carbon is known as chiral carbon. So you can say carbon, second carbon is chiral carbon. Chiral carbon. Okay, you can check this carbon also, but this carbon is attached. See, this is CH2, means 2 hydrogens are there. Okay, 2 hydrogens means same hydrogen ho gaya. So this is not a chiral carbon. Again, 3 hydrogens are there and 1 CH2 group is there. So again, this is not a chiral carbon. Okay, so only one chiral carbon in this molecule. Okay, and the carbon, that carbon, chiral carbon is carbon 2, second carbon. Okay, this carbon. Clear? Okay, so write down one question. This is from your NCRT example. Example from your NCRT. Identify chiral and achiral molecules in each of the following. In each of the following. In each of the following pair of compounds. Okay, and basically these molecules are the structure of these molecules are given in a wedge and dash representations. Okay, so basically आपने ये class 11th में पढ़ा होगा wedge and dash. What is wedge and dash representation and how we can draw the wedge and dash structure. Okay, so this is your first option, A option, A question. Basically in the question number A, there are 2 options. First option is, first molecule is, this is your carbon, and this carbon is basically hydrogen, and this is your OH, and this wedge, this is your bromine. Okay, and this is your CH3. Okay, first molecule. Second molecule is carbon attached, hydrogen is attached, here the bromine is attached, and here bromine and your CH3. Okay, so in question number A, you just have to identify which one of these 1 and 2 options, which one is chiral and which one is achiral. Similarly, second question is carbon CH3, This is the first. This is the second option. Okay, this is the second option. C question, C part. First option. Okay. Yes, first one. Yes, Jubita, first tell me
The first option.
which option is achiral and which one is achiral?
The first one.
Yes,
First one
very
is
good.
chiral.
Yeah, first one is chiral. Very good. And this one is your achiral. Achiral. Okay, because this is your carbon and carbon is attached to this hydrogen, hydroxyl group, bromine and methyl. And all the groups are different. Okay, and in this, the bromine and bromine, these are similar, so it is chiral, achiral. This carbon is achiral. Okay, second, tell me, Muniba, which option is chiral, first or second?
The first one.
Yeah, very good. The first one is chiral. Okay, as this carbon, and which one is chiral carbon? This one is chiral carbon. Okay, this is your methyl group, this is the hydroxyl, this is your group, and this is your another group. This is your another group, so this is your carbon. Third one, Anisa, tell me. This is your achiral. Because this group, okay, this group basically, this is your CH2, CH3 means ethyl group. To this carbon, ethyl group is attached. This ethyl group is attached. Okay, and both are similar, so it is not a chiral. It is not a chiral. Yes, Anisa. Third, C question. Which one is chiral molecule? First या second? Yes, Anisa. Check the carbon, number the carbon, and just check the groups which is attached to that carbon. Group should be different. Okay, you can this hydrogen is there, right? So you can hydrogen को भी आप एक atom ले सकते. The hydrogen is attached. Hydrogen is one group. Methyl is another. The bromine is another, and the CH2 is another. This whole group is another, right? So obviously, the first one will be your chiral. First one will be your chiral, and which one is your chiral carbon? So this is your chiral. Second, this is your chiral molecule, and this is your achiral. Right. This is your achiral. Okay, now is it clear? Now you can find which one is chiral and which one is not. Okay. Okay, so today we have to complete the chapter, but I think ये possible नहीं हो पाया. There are some topics which are left, like optically active compounds. Okay, enantiomers क्या होते हैं, plain polarized light क्या होते हैं. So there are some small topics which are left. So we will cover in the next class. And in the next class also, we will discuss some most important questions from your book NCERT and the previous year question, जो आपके course में आ चुके हैं, right? So we will discuss that. And after that, after that class, we will start with the alcohol, phenols, and ethyl. Okay. So that's all for today. See you guys in the next class.
Okay, ma'am. Thank you. Bye.
Bye. Thank you.
Thank you,
Take
ma'am.
care. Bye bye.